Hi students, as promised, we are back with the numericals related to the chapter Calorimetry. These are the questions which have appeared in the latest Icse specimen and other board papers. So don't skip, watch till the end and try to score the best in calorimetry. Okay, so first question, a solid of mass 60 gram at 100 degrees Celsius is placed in 150 gram of water at 20 degrees Celsius and the final steady temperature is 25 degrees Celsius. Okay, so on combining this two, the temperature of the mixture finally reaches to 25 degrees Celsius. We need to calculate the heat capacity. Okay, heat capacity we know it is C dash. What we are going to do is first we will calculate C. C is called as a specific heat capacity. We have already discussed the relationship between heat capacity C dash and C. We know that C dash is equal to C into mass m. Okay, so first let's calculate the value of specific heat capacity C and then we will move on to calculate the value of heat capacity. Okay, so let's try solving it. Here it is given that the mass of the given solid is 60 grams and the temperature is 100 degrees Celsius. Okay, mass of water is 150 gram and the temperature is 20 degrees Celsius. The final temperature is found to be 25 degrees Celsius. Okay, so here the change in temperature of solid is 100 minus 25, which is 75. Okay, and the change in temperature of water is 25 minus 20, which is 5. Okay, so according to the principle of calorimetry, let's say Q1 be the amount of heat energy lost by the solid and Q2 be the amount of heat energy gained by water. According to the principle of calorimetry, both are the same, okay, or both are equal. So moreover, there is a temperature change. So we can use the fundamental equation Q is equal to mc delta T. Okay, remember, whenever there is a change in temperature, we can use the formula Q is equal to mc delta T. However, if there isn't a change in temperature, we can use the formula Q is equal to L into M as in the case of latent heat. Okay, so here we can use the formula Q is equal to mc delta T. Here equating the two, mc delta T of solid is equal to mc delta T of water. Okay, so we are not yet told about the specific capacity of solid, so let it be C. So here the mass, here the specific capacity of the solid, and here is the delta T or change in temperature of the solid, which is equal to, here is the mass of water, here this is the specific capacity of water and this is a change in temperature of water. Equating the two, we get C is equal to 150 into 4.2 into 5 divided by 60 into 75. Okay, and this appears to be 0.7. Okay, and the C appears to be 0.7. Now to calculate C dash, we know that C dash is equal to C into M. We have got C is equal to 0.7 into mass of the solid is 60, upon multiplying we get 42. Okay, 42, the unit is joule per Kelvin. Okay, so now we have got that the heat capacity of the solid is 42 joules per Kelvin. Okay, you should not forget to calculate the heat capacity, because in the question it is asked about the heat capacity. Never end your answer with calculating the specific heat capacity. The question is asked to calculate the heat capacity, so you should be knowing the fundamental equation C dash, the heat capacity C dash is equal to specific heat capacity multiplied by mass of the given substance. Okay, I hope this question is clear. Moving on to the next one. In an experiment to measure the temperature of the flame of a Bunsen burner, a lump of copper of mass 0.12 kilogram is heated on the flame for a longer time. The copper is then quickly transferred into a beaker of negligible heat capacity. Yes, this is what I have mentioned in the previous basic class. If it is mentioned the question to consider the heat capacity of the solid or the solid container in which the mixture is taken, you will have to. But here it is directly hinted that it is of negligible heat capacity, so you need not have to bother about the amount of heat energy absorbed by the container in which it is kept. Okay, so let's leave about the beaker and let's further proceed. Okay, containing 0.84 kilogram of water. So here the mass of copper is 0.12 kilogram and the mass of water 0.84 kilogram, and the temperature of the water rose from 15 degrees Celsius to 35 degrees Celsius, which means that the final temperature of the mixture is 35 degrees Celsius and the water, which was initially at a temperature 15 degrees Celsius, has gained some energy to convert its temperature from 15 degrees Celsius to 35 degrees Celsius. Now we are asked to calculate the temperature of the flame. Okay, given that the heat capacity of copper is 0.2 joule per gram per degree Celsius, you need to be very cautious while handling the SI units. Okay, here it's the heat capacity is given in joule per gram. Okay, so it would be better for us to convert this given kilograms into gram and then solving it. Okay, it would be a much difficult or rather tedious task to convert this into gram from converting this into kilogram. Instead, it is much easier for you to convert this kilogram which is given in the question to gram and then proceed solving it. Okay, so let's try in that way. It is given. Okay, let's consider the mass of copper is 0.12 kilogram and the mass of water is 0.84 kilogram. We are not known about the temperature of copper. So let's say the temperature of copper is T. Okay, but the initial temperature of water is 15 degrees Celsius and the final temperature of the mixture was observed to be 35 degrees Celsius. Okay, let Q1 be the amount of heat energy lost by copper. So let Q1 be the amount of heat energy lost by the copper and Q2 is the amount of heat energy gained by water. Okay, by principle of method of mixtures, we can equate the two because heat energy lost by the hot object is equal to heat energy gained by the cold object. Okay, so here there is obviously a temperature change, so we can use our fundamental equation Q is equal to mc delta T. Okay, we can use this equation. So here mc delta T of the copper is equal to mc delta T of water. Okay, you should be knowing that copper, which was initially at the temperature T, has now lost its temperature and have reached to 35 degrees Celsius. So the change in temperature of copper is T minus 35 because T was probably a higher temperature and 35 is a temperature which is comparatively lesser than it. Okay, so the change in temperature of copper is T minus 35 and the change in temperature of water is 35 minus 15, which will be 20. Okay, so equating, we get, let's leave this T minus 35 here and bring 0.12 into 400 to the side. On solving, we get T minus 35 is equal to 1470. Okay, so T minus 35 is equal to 1470. Upon bringing this 35 to the right hand side, it becomes plus. So T will be equal to 1470 plus 35, which will be 1505 degrees Celsius. So the temperature of the copper and indeed the temperature of the flame was 1505 degrees Celsius. Okay, I hope this is clear now. So now let's move on to the other question. Here it's given, what mass of ice at 0 degrees Celsius? Okay, what mass of ice at 0 degrees Celsius must be added to 2.1 kilogram of water will cool it down from 75 degrees Celsius to 25 degrees Celsius, given that the specific capacity of water is this and the specific latent heat of ice is 330. So let's try to understand what happens here. Okay, so when we add ice at 0 to a water which was initially at 75 degrees Celsius. Okay, here the temperature changes. What happens in such a reaction is that first ice at 0 changes to water at 0 and this same water at 0 changes to water at 25 degrees Celsius. Okay, this is with respect to the ice which we have added. What happens to the ice is this. Okay, ice at 0 first changes to water at 0 degrees Celsius and then this same water at 0 degrees Celsius changes to water at 25 degrees Celsius. Okay, so the overall changes here, ice absorbs the heat energy Q is equal to L into M and here it absorbs the heat energy Q is equal to MC delta T. And what happens to the initial water, this 2.1 kilogram of water, what happens to this water is that it loses heat energy. Okay, it loses heat energy and gets converted from water at 75 degrees Celsius to water at 25 degrees Celsius. Okay, so here ice gains heat while the water in this 2.1 kilogram of water which was initially in the container loses heat energy and it gets converted from 75 degrees Celsius to 25 degrees Celsius. Okay, this is what happens to ice and this is what happens to the water which was initially present in the container. Okay, so let's look at it. Ice at 0. Okay, here what happens is the ice which was initially at 0 degrees Celsius, the mass it is unknown, let it be m kilogram and the latent heat is given, it is 336, and water which was initially at temperature 75 degrees Celsius and the mass is given to be 21 kilogram. Okay, so converting it into gram, it is 2100 grams. Why do we convert it into gram? Because it's given 336 joule per gram and it is also mentioned 4.2 joule per gram, so it is better to convert the mass into gram. Okay, instead of converting this into joule per kilogram, it's better for us to convert this into kilogram, this kilogram into gram, because all we need to do is just multiply with 1000, but here we need to divide it by 1000. It becomes a bit difficult. If you want, you can do in that way too. Okay, I now presume to do this in this method. So let me convert this kilogram into gram and then proceed solving it. Okay, so I've converted this mass in kilogram to mass in gram, and given the specific capacity of water is 4.2 and the final temperature is observed to be 25 degrees Celsius. Okay, this is what I have explained earlier. This is already what I have explained earlier. What happens to the ice is ice at 0 degrees Celsius first changes to water at 0 degrees Celsius. Okay, this ice at 0 first changes to water at 0 degrees Celsius, and here it absorbs an energy which is equivalent to Q is equal to L into M. And this water, from where this is water obtained? It is the water is obtained from the melting of the added amount of ice. Okay, so that water at 100 degrees Celsius later convert to water at 25 degrees Celsius by absorbing the heat energy. Q is equal to mc delta T. Okay, so the heat gained by the ice during the complete process will be the sum of these two quantities of heat energy, which will be Q1 is equal to L into M plus mc delta T. Okay, but we are unknown about the mass, so let it be M itself. So L is 336, so 336 multiplied by M plus M into C into delta T is 25 degrees Celsius. Upon solving, we get 441 M. Okay, and let Q to be the amount of energy lost by water. It's already understood that water at 75 degrees Celsius get converted to water at 25 degrees Celsius. So the delta T is 75 minus 25, which is 50 degrees Celsius, and the mass is already converted 2100 gram into 4.2 into 50, which is 441,000. Okay, by principle of method of mixtures or the principle of calorimetry, we can conclude that the heat lost by the water will be equal to heat gained by the ice. Okay, that is Q1 is equal to Q2. On equating, we get Q1 is equal to Q2. We get 441 M is equal to 441,000. On solving, M is found to be 1000 gram. Okay, 1000 gram is equivalent to 1 kilogram. So the quantity of ice that must be added so that the final temperature becomes 25 is 1 kilogram. You need to add 1 kilogram of ice into the mixture into the water 75 degrees Celsius so that the final temperature reaches to 25 degrees Celsius. Okay, once again I'm explaining the key concept. This is what you have to know. Okay, what happens to ice at 0? Ice at 0 first changes to water at 0 degrees Celsius. Okay, and this very water at 0 degrees Celsius later converts to water at 25 degrees Celsius. How do we come to know about it? Because it is given in the question. Okay, it is given in the question that the temperature of the mixture finally gets converted to 25. That means the ice which was initially at 0 degrees Celsius has melted to water at 0 degrees Celsius. Water at 0. This water at 0 cannot remain at 0 degrees Celsius because the temperature of the final mixture has now converted to 25 degrees Celsius. Okay, so this water which was formed by melting of ice at 0 must gradually increase its temperature to 25 degrees Celsius, which will absorb a heat energy. Q is equal to mc delta T. Okay, so here what happens is ice at 0 first changes to water at 0 by absorbing Q equal to L into M amount of heat energy, and this very water at 0 degrees Celsius get converted to water at 25 degrees Celsius by absorbing Q is equal to mc delta T. So the overall gain in heat energy by the ice at 0 to be converted to water at 25 is that the sum of L into M and mc delta T. Okay, and the amount of heat energy lost by water at 75 degrees Celsius when it gets converted to water at 25 degrees Celsius is Q is equal to mc delta T, which is given here on. Now by applying the principle of method of mixture, we get M, the mass of ice, to be 1 kilogram. Okay, I hope this question is clear, and let's see in another video discussing other problems. Okay, if you find this useful, please do like, share, subscribe, and comment your queries, and you can also comment the chapters or the problems which you want me to make a video on for the next coming days. Okay, thank you.